Now, constructor is really nothing more than a special method that's called whenever you create a new instance of a class. The constructors are really easy to identify within the structure of a class because the name of the constructor will always be the same as the name of the class. They're identical. The constructor also has the ability to accept parameters if you wish. So you can feed data into the class when the class is instantiated. If you don't define a constructor of your own, the compiler will create one for you. Now, that's kind of interesting because up to this point you probably noticed that we have not been defining constructors in any of our classes. That doesn't mean that the constructors don't exist in our classes. We've just been depending on the compiler to do the creation of the constructor for us. Now, if you don't create a constructor and the compiler is allowed to create one for you, you will get what's called a default or zero parameter constructor. It's a constructor that does not accept any parameters, and it actually really doesn't do anything at all. However, it's there. That's the point. It provides a structure that you can use to create instances of your objects. Now, the real purpose for constructors is to give us the ability to feed values into the class upon instantiation through parameters, or within the constructor do other special work and operations. One of the nice things about constructors is that they can be overloaded. Overloading a constructor, of course, means that you have different versions and that differ in terms of the type and number of parameters that they accept. So if the constructor is overloaded, that means you have different options on how you're going to be creating and instantiating those classes. Now, if the values that you're trying to set within the constructor are essentially constant, then you may want to consider just using an initializer instead. Instead of, for example, capturing a value which is going to be the same all the time and assigning it to a variable, you can simply initialize the variable, as in this example, int myval equals 5. You can do that initialization at the point that the class is defined, rather than having to do that within the structure of the constructor itself. In this example, I've created a class called square. The square class defines two private data members, length and width. If I want to set side values for the square, the length and width of the square, I'm going to have to find some way of passing the data in so that these private values can be set. Well, I've decided to accomplish that using a constructor. I've got two constructors that I've created here, so the constructor is overloaded. The first constructor, entitled square, is a public constructor, which means that from outside this class, wherever this is publicly available, I can instantiate this class simply by passing parameters into the instantiation statement. I'm passing in two parameters, double L and double W. Now, the length variable here is going to be assigned to the parameter L, while the width variable will be assigned to the parameter W. The other constructor I've defined simply has a single parameter, a double called S, which I'm using as a side. Since the side measure of a perfect square is equal for all four sides, then I'm setting length equal to width equal to the parameter S. I've also defined a method of my class called area, and the area method returns the length times the width, so that way I can get the area of my square. Now, to call the constructor, I simply use the standard instantiation statement here in my main method. Square S equals new square. Now, remember that when we've used this instantiation process previously, after the name of the type that we want to create or class we wish to instantiate, we have an open and closed paren. The assumption there is that we're calling a zero parameter constructor. In this case, however, we do have parameters that we need to pass into the constructor. So technically, as we revisit this instantiation statement, square that's being used here defines the type of object we're creating, and this reference to square is basically a call to its constructor. So I'm passing in 5 as the value of the width and the length of this particular square. Then I'm simply going to call the area method to write out to the console the area of that square, which should be 25. Let's execute that and see what we get as a result. According to our resulting window, 25 is the return value of the area of the square. So that means that the values have been passed in successfully. Let's go back and make a little change. What if I change one of the arguments from 5 to 10? That should change the area because that will change the width of the square. Let's execute this again. And as you see, we do have the appropriate change reflected in our output. Now, what if I only passed in one value instead of two? Let's take out the comma 10. We're passing in simply the value of 5 as a parameter. That means that I should be calling the second constructor instead of the first. So the length and the width will both be set to 5. Therefore, the area, once again, will be 25. Upon execution, we get exactly the result that we would expect. So as you can see, the constructors are useful for providing ways to pass values into that class upon instantiation of the class. I could also use the constructors to set other values, parameters, setup, initialization, etc. as I wish. In these cases, I have public constructors. Be aware that you can limit the accessibility to the instantiation of this object by limiting the accessibility of the constructor as well. Using private, internal, etc. would limit the availability or accessibility of the constructor and thus limit the scope from which you could actually instantiate the class. Now, if you like, you can create a destructor that looks like the syntax you would use in C++. We just use a tilde before the name of the class and then open and close parens. Then you put the destructor logic within the curly braces inside the body of the destructor method. Although the C++ syntax is provided, it's really nothing more, though, than a shortcut to a finalized method that is defined by C#. So rather than having any confusion here, the preference probably, instead of using the C++ syntax, the preference would probably be to create physically a finalized method within your class. So that finalized method, this is referred to as the destructor. Now, the finalized method is never explicitly called. So just like the constructor, the finalized method is implicitly called by the system when you're executing a specific process. Now, if you set an object variable or a reference variable equal to null, that removes the reference to the object. You would think that at that point the destructor would be called. Well, that's not necessarily the case. The finalized method is called by the garbage collector. The garbage collection process happens in the background basically as resources are necessary. So we have no real knowledge of exactly when the garbage collection process will take place. For that reason, you never know exactly when the finalized method will actually occur. So if you want to control exactly when some of those resource cleanups take place, for example, things that you would put inside that destructor, you may want to consider using a dispose method. Now there's an interface that we can use in C# called iDispose that supports a dispose method that does get called when the references are terminated and the object is physically made available for garbage collection. So if you want more resource control, we can use the dispose method of the iDispose interface. We will talk more specifically about this dispose method as we discuss interfaces later.